Okay, so today we're just going to practice limits. So I have 6 examples for us. And when we get through those, we get through those. Then at the end of class, if you have questions on the homework or need to stay to ask any questions, it'll be like built-in office hours for today. Like I said earlier, I'm going to probably be kind of swamped today at 2. Does not mean that you can't log in at 2. Always feel free that you can. I just already have like 5 kids apparently coming. So I just didn't want to be overwhelmed at that time. So I'll kind of build that into the end of class today. Math is a crazy beast, you know? Okay, let's do this on the whiteboard. So what I'll do is just put the problem up. The first one's graphing, so it'll just take a second for me to draw. The other ones are algebraic. Thanks, John. And then I'll just call on you guys randomly. If you don't know, no biggie. You can, ooh, maybe we'll do it. You can nominate a friend. That'd be fun. Okay. All right, let's draw. All right, so 2, 0, and 2, -1 as a whole. Okay, so we'll do kind of what we did yesterday. We'll look at the x value of 2, since that's where we have a discontinuity. Did you guys get to go outside yesterday in the beautiful sunshine?
Absolutely not.
What?
Absolutely not.
Did anyone get to enjoy the sun? It was so nice yesterday.
Weird.
I went outside for a little bit.
Good. Me too. It was so nice.
I forgot what outside felt like. Forgot outside was even a thing. I might be going insane, Mr. Miles.
That's okay. What else is new? Okay.
Hey. Yo.
I do have a part E that we'll just do talking because I'm not going to be able to fit it. That's fine. All right. I'm going to call. I'll give you guys just a second here.
Good, y'all. Good.
I was talking about Divine.
All right. I'm going to start with Stash for part A.
Oh, we going fast.
0.
0. Okay, Stash, pick somebody for part B.
Mauser.
Yeah.
-1.
Nice. Okay, Mauser, you pick someone.
Josh.
Yo, you wildin'. Hold on. The jump going to 2. See the name. I say 0.
Yeah, Miles.
Ethan, what'd you get for part C?
DNA does not exist.
Does not exist. Why is that, sir? You're right.
because there's a removable discontinuity, and they're not, A and B are not the same.
A and B are not the same. You're absolutely right. So in order for the overall limit to exist at 2, we have to be approaching the same y value from both sides, and A and B show us that we're not. Cool. Let's take a look at, go ahead, Ethan, and pick someone for part D.
Brendan.
Go.
Go.
0. Hey.
All right, nice. So this is actually a jump discontinuity, because even filling in this hole wouldn't like fix the discontinuity. We jump from a y value of 0 down to a y value of -1. So this is a jump discontinuity. That's why our limit does not exist there. Nice. Okay, the next ones are algebraic. So not as bad. Okay, let's do the limit. Jeez. The limit is x goes to 0 of a fraction 2x to the 7th minus 8x to the 4th over 5x to the 4th plus 10x to the 5th.
Wow.
Give you guys a minute or two to start.
I did.
Okay.
I took the like the greatest common factor from the numerator and denominator.
Awesome. Why did you know you had to factor this one? What's our very first thing that we should do with a limit?
Plug 0.
Yeah, just plug it in. So if we plug in 0, we'll get 0 over 0, right?
Yeah.
And that's indeterminate form. Great. So then you did the next step to actually evaluate the limit, which needed to be factoring. Great. What'd you get for the GCF up top?
2x to the 4th.
Cool. And what was left?
X to the 3rd minus 4.
Nice. Okay. And then do you want to keep going, or do you want to have someone do the denominator?
I can do it. I don't know if it's
Okay.
right, but I just want to make sure.
Okay.
The greatest common factor was -5x to the 4th. And then it's 1 minus 2x.
Okay. You don't need to make it negative. Just because there's no negatives in the denominator. You know what I mean?
Oh, I misread the regular question. I thought
Okay.
that was negative.
Fine. You have the right value, it's just the wrong sign. It's okay. Cool. Looks good. Okay, nominate someone to do the next step.
Dylan?
Why did I know he was gonna pick Dylan? Okay.
Oh.
What can we do, Dylan?
There's you.
I was trying to find my notes from the first class.
Oh.
Go.
Well, can we cross something off top to bottom?
It's like the x to the 4th. I mean, like it's something like that. All right.
Good.
Yeah.
Good.
Okay, nothing else can cancel out.
Thanks, B.
Okay, Dylan, pick somebody for, or unless you want to tell us what we can do next.
Oh no. Miles, you got it?
Yeah, I got you. Distribute both the 2 and the 5.
Say that one more time.
Distribute both the 2 and the 5.
Okay, that's totally fine. You can do that. You want to distribute the 2 and the 5?
Sure.
Okay, cool. We can do that for sure. If we distribute the 2, so I'm going to show you 2 ways that you can do it. You don't have to distribute the 2 and the 5. And then I'll do a way where you can distribute it, and we'll see that we get the same answer, okay? So this would be not distributing the 2 and the 5. And then what'd you get when you did distribute it?
I haven't gotten that far yet.
Okay.
You get 2x third minus 8 in the top, and then in the bottom you got 5 plus 10x.
Okay, awesome. So you can do either the method that I'm outlining in black or blue. Either way is fine. We'll end up getting the same answer. Do you want to keep going, Miles, or do you want to pick somebody new?
I'll pick somebody new.
Okay, someone that hasn't gone yet.
All right. Is Hiller here? Hiller?
He is.
You can then like plug in the 0.
Yeah. Here's what I forgot to write in front of each one of these. It's still the limit as x goes to 0. Whoops. I don't have room here, but the limit as x goes to 0. Cool. So if we plug in 0 here in black, we'll be left with 2 times the negative 4, right up top. Hiller, what will we be left with in the denominator?
5.
Yeah, awesome. 5 and then just a 1, right? So we plugged in 0. And then, because I'm showing you 2 different ways, I'll do the method in blue, right? These are just alternate ways of looking at it. Miles suggested distributing the 2 and the 5 through, which you can do or you don't have to. So I'm also gonna plug in 0 down here with the blue, where we just distributed the 2 and the 5. And look what happens. We end up with a negative 8 over a 5 when we plug in 0. Okay, and then I'll just finish it up from here. In the top, we'll have negative 8/5, and same with down here. So either way, distributing, not distributing, the idea was that because we got, who remembers what 0 over 0 is called from the jump?
Indeterminate.
Nice, indeterminate form. When you get indeterminate form, which in math is 0 over 0 or infinity over infinity, we're just not going to deal with that one this year. We have to do some algebraic manipulation. Nice job. Great. Okay, next one. Who do we ended with Michael, right? Okay, so Michael, you'll get to pick the person who starts us off for number 3.
Okay.
To the limit as x goes to 5 of x, so a fraction again, x squared minus 4x minus 5 over x squared minus 25.
Kobe.
All right, Kobe, walk us through it, bud, if you're ready.
All right, so for the first one, the numerator, you want to factor it, and you'll get x minus 5 times x plus 1.
And why did you know we had to go into factoring?
Because it would be 0 over 0 if not.
You got it.
All right.
Cool. And how did you get x minus 5 and x plus 1? That's right. What was your thought process?
Just factored it, what multiplies to negative 5 and adds to negative 4.
You want to keep going, or do you want to nominate someone new?
I can do the denominator.
All right.
And then on the bottom is the 2 squares.
Nice.
So you just do x plus 5, x minus 5.
Cool. And I love that Kobe said it's a difference of 2 squares. Yes, difference of squares. I feel like that's something that students have such a hard time remembering for some reason, but we literally call it like we see it in math, right? It's a difference, it's a minus sign, and both are literally perfect squares. Okay, Kobe, go ahead and pick somebody to walk us through the next step. Arthur.
My bad. So for the next step, wouldn't we just? Sorry.
Okay.
Wouldn't we just cross out x minus 5?
Nice. And then what can we do from there?
We can then wouldn't it be just the limit x plus 1 over x plus 5?
Yes. You want to go one more step, or do you want to nominate someone else?
Yeah, I'll nominate someone else.
Okay.
Stash.
Let's see. Stash. Okay.
Better be awake.
You would substitute the limit as x approaches 5, so it'd be 6 over 10, which
Nice.
simplifies to 3 over 5.
Nice job, Stash. Thank you. Thank you, guys. So we plugged in 5. And it worked now. We no longer got 0 over 0. Okay, I'm going to give you guys one that I want you to just try on your own. I'll give you a couple minutes just to practice it by yourself, and then we'll just walk through it together. Remember, you want to first direct substitute no matter what, because if that gives you an answer, you're done. You don't have to do any factoring or anything else. Okay, so our first step when evaluating a limit is to direct substitute. So let's direct substitute in -1. If we do that, our numerator will be 5. And then if we direct substitute a 1 in down below, I'm just going to kind of do part of this in my head because this isn't too bad, right? So if we square -1, we'll get 1. And then if we multiply by 5, we'll get -5. And then we had a -6. So the denominator, this gives us -4 minus 6 more. And we got a number, right? Which we can simplify to -1/2. So yes, this denominator is factorable, right? It factors into x minus 3, x minus 2, or is it, no, sorry, x plus 6, x minus 1. But we do not need to factor it. There's no need because we don't get indeterminate form when we plug it in. So when you can just direct substitute, do that. That means there's no issue at -1. It's continuous there. The limit exists and the function value are both -1/2. Let's try another one. A little bit of trig. Just means find the tangent at pi over 6 and then square it, right? So we're going to direct substitute. So when we direct substitute in pi over 6, this means, it means find the tangent at pi over 6 and then square that value. That's what that squared means.